introduce the session and the panels this afternoon. We have a rich agenda this afternoon. It's an agenda that's both very pertinent to the climate change global agenda, and we also have an exciting set of interventions. Our overall perspective is to look at the role of data, observing systems, forecasts that lead to better response, early warning systems to deal with the climate change impacts. And the way we've organized ourselves is that we're going to have the session will be divided into two interlinked panel discussions. Let me start by just mentioning the latter discussion that will take place immediately after this panel. We'll be looking at open data and local capacity to support the global response to climate change. And it's organized by EUMETSAT, Copernicus, and other partners. And the initial part of this discussion is a panel that is organized by France and the crews, and it's going to be looking at global regional forecasts that lead to early warning actions on the ground. I'm going to pass the floor to the two panelists. Before that, I would just like to refer to one global trend which I think frames quite nicely our discussions this afternoon. And that's the fact that over the last 10 years, we've made collectively at a global level tremendous progress in our capacity to collect data, to share data, to observe what is going on at all levels on the planet, to provide better forecasts, better predictions, longer-term predictions. We've also got better at preparing our communities, getting more to deal with that information. And as a result of this quiet revolution that has been ongoing in the world, the number of people dying from disasters is trending down. It's one of our, let's say, global successes. However, that trend is not the same for the lower income countries and small island states. And if we look at the data, in those countries, the number of casualties, the casualty risk to extreme climate events is actually trending up. And I think this is something which is obviously not acceptable, but it is reversible. So today we're going to have quite a lot of very practical interventions from a wide range of experts who are going to be showing how we're trying to address this underlying trend in the global climate change agenda. So I would like to invite, we have two speakers in this first panel. The first one is Maxx Dilley. He's the director of the Climate Prediction and Adaptation branch at WMO. More importantly, he has a long career of experience in developing systems that help countries deal with the impacts of extreme events and climate change. And the second speaker is Michel Nikiema. He's the cruise project manager for Burkina Faso, and he works at the Agence Nationale de la Meteorologie in that country. I'm going to first ask Maxx to give his presentation, about 10 to 12 minutes max. I will then continue directly with Michel Nikiema, and we will then like to open the floor. Both the speakers have encouraged this to be an interactive discussion, so after both of the presentations, we'll open the floor for questions to both of them. Thank you.
Okay, thank you, John. I thought you were going to say a little bit more about cruise itself, so maybe I'll pick you up where you left off. Climate Risk and Early Warning System is an initiative that was championed by the government of France and launched at the Paris COP. And it has a very unique structure in which there are 6 donors who are members of the steering committee. John and his colleagues provide the secretariat for the steering committee. And then we have 3 implementing partners, one of which is the World Meteorological Organization where I work. And then we have the Global Facility for Disaster Risk Reduction, which is part of the World Bank, and then the UN International Strategy for Disaster Reduction. And these partners work with countries to prepare work plans that are then presented to the steering committee, and if they're approved, the World Bank, which is the trustee, releases the funds and we can begin implementation. So what Michel and I are going to do today is work through two of those initiatives to try to show you how we're using this cruise initiative and its structure to try to make a significant improvement in the societal outcomes that are experienced by real people who are living in some very difficult conditions and whose livelihoods and well-being are often very tied to fluctuations in weather and climate. And our colleagues here from NM, the Burkina Meteorological Services, are very much on the front lines of that, and so I expect Michel will talk about the services that they hope to be able to deliver in the country. I'm going to talk about a regional support project that was just approved by the Cruise Steering Committee earlier this week that will support the work in Burkina Faso, but also in two other countries in Mali and Niger, which have very similar climate conditions. So we will be talking about projects, which I know sometimes it doesn't seem like the most high-level thing, but we hope that this is illustrative of how this value chain is being hooked up in a way that could hopefully do some real good. So I'll start on the regional level, and then we'll move to the country level. So I'll just sketch out how, on a programmatic basis, the various projects that are being approved or have been approved through Cruise work, and then I'll talk about the regional work plan before Michel talks about what the country part will do. So in Burkina Faso, this is just to introduce your talk, there are two basic components. One is focused on what we call the basic systems. Now, basic systems are the nuts and bolts that most people don't ever see that are behind all weather forecasts, all climate projections, everything that you get as a citizen comes out of these basic systems. But then if it stops there, it's not useful, so we have what we call service delivery, which is converting all of that climate data, those forecasts, into something that helps the general public or some sectoral decision maker make a better decision. And so this, in Burkina Faso, we're focusing on early warning systems for floods and agriculture, and the basic systems on the left are what is going to support that. But in two other countries, we have a different configuration. In Mali, there is, on the left-hand side, a big component on institutional strengthening. But on the right-hand side, and I've circled it here, you've got that basic systems component again, the flood and drought forecasting and the warning services. And then in Niger, where there is yet another cruise project and plenty of other projects, and I'll mention that later, there is also, again, this institutional component on the left, and on the right there is this, this basic systems plug-in, in this case, dissemination of warning services and the information bulletins that come out of them. So with that introduction, we have a West Africa regional work plan which focuses on setting up seamless operational forecast systems and technical assistance. It's costed at about $1.85 million over 3 years. And in that work plan, we will involve some of the meteorological services who indeed helped design this work plan from Europe, who will basically be partnering with counterpart centers in the Africa region and in the West African countries that I mentioned. So KNMI here is the meteorological service of the Netherlands, and Deutsche Wetterdienst, obviously, from Germany. Some other centers from around the world. And then there are the three regional centers in West Africa: ACMAD, African Center for Meteorological Applications and Development, AGRIMET, and the Regional Specialized Meteorological Center in Dakar. So we have a kind of a three-level support system here with some meteorological services with global reach, some regional centers and some national centers. And the key is to try to link them up. So this is our objective. It's a bit of a mouthful, but it was very carefully crafted. So we're looking to establish an operational severe weather, flood, and climate forecast system underpinned by ongoing observations and continuously updated historical data that provides monitoring and forecast outputs and products as well as related knowledge in support of the cruise-related activities in Burkina, Mali, and Niger, and the other countries in the region by helping the regional centers to begin to provide, well, they already are providing, but to strengthen their ability to provide these basic system outputs that the NMHSs in the countries can also add value to and then convert into products and services. So I think this is my last slide. It shows in a schematic way how this works, and I'm just going to spend a little bit of time on this diagram because it took us about 6 months of work to finally figure out how to structure this whole thing. So at the middle of it, you see this kind of gray band across it, and this is a country situation or a country work plan in the cruise parlance. And so Burkina Faso will be one, but there were the two others that I mentioned. And so in Burkina Faso, as you saw, there was a stakeholder consultation, and the demand was for flood forecasts and agricultural services. In some of the other countries, it's also flood forecasts, but there could be some different sectors. And so at the country level, there will be a big effort to try to make that direct connection with early warnings, with specialized products for agricultural decision making, and communicate those to people working in those sectors or who are affected by floods so that they can take actions to save lives, property, and protect livelihoods. But to support that, there will be a need, and this is how every meteorological service in the world works, for forecast model outputs that come from regional and global centers. So I live in Switzerland. I get every day, any minute of the day, on my phone, a very, very detailed precipitation forecast that I use to time my bike ride to and from work. But that forecast starts at the European Center for Meteorological, for medium-range weather forecasting on a supercomputer that is ingesting observations from around the entire world. Meteo Suisse takes the outputs from that model and they add radar data and their own local area model, and that's how I get this very high resolution spatial and temporal precipitation forecast. But producing that requires ingesting data from around the world. So this blue band here on this diagram shows basically where those outputs would come from on the full time scale that the country projects will be dealing with. The sort of climate monitoring and nowcasting, the severe weather, the flooding, and the subseasonal to seasonal forecast. So that's what goes across the top. And in the middle, in the pink, is the interface between the global and the regional centers and the national centers of data exchange going both ways, data and products. So there will be information coming up from the countries that are going into the region and the global level, and plenty of information and products coming down through that interface that's shown there in pink. And then on the top, we have the management part, which is not interesting for this discussion. So that I have just one more thing to say about this slide, and then I think I've finished my part. Any country, practically, that you go to now, when you start scratching the surface, you're going to find that there is another $50 million or $100 million or $200 million or you name it, of other projects already going on. And these may or may not be involving the Meteorological Service. They may or may not be being implemented on any kind of a structured technical basis like the one I've tried to outline here. But there's a lot of money there, and one of the advantages of cruise is that because of this partnership between WMO and the World Bank in particular, we have an ability to try to link those projects up. The big investment projects with these much smaller scale, more narrowly technically focused projects. So the white part at the bottom of the diagram here shows that in all of these countries there are Green Climate Fund projects, there are pilot program on climate resilience projects, there are World Bank loans that are all either planned and in operation. And we're hoping that by getting the data flowing and the forecast support flowing and the products flowing, that we'll be able to upscale that service delivery chain with some of these bigger projects that are ongoing, that we will eventually hopefully be able to link in. So it's a small kernel that has sort of big ambitions in terms of what it's going to try to achieve. So I've covered the regional part, and now I think I'll stop and turn it over to Michel to talk about what they're doing at the country level.
Thank you, Max.
I don't know, how do we...
Thank you very much, Max, for being so timely and precise and managing to explain a pretty complex setup and how it actually it's functioning. So as I suggested, if you could please keep your questions, remember your questions also to Max, and then pass, and we'll listen to Michel Nikiema first, and we'll open the floor after that. Over to you, Michel.
Okay, thank you. And thank you, Max, for your presentation, because you have said it all almost, but I have to say something. So, strengthening national capacities for early warning system service delivery in Burkina Faso. First, I will just show where the country is. It's located in the middle of West Africa. It's a landlocked country with a population of 18.1 million. And 45% of the people are living with less than $2 per day. And the economy is mainly dependent on agriculture. And we have also 80% of the active population, doing this activity. And we have some major risks like drought, flood, crop pest invasion, strong winds, dust storms, heat waves, and seasonal epidemics. And these are having a negative effect on most sectors such as agriculture and livestock and water management. And I can show some example. This one is the one on the left panel. The 1st September 2009, we got less than 24 hours, a quantity of 263 millimeter. Generally, this quantity is for 1 month during the month of August, which is the peak of the rainfall. But it just fall one day, and after that, we didn't get any rainfall again up to, it just closed the season. And on the left panel, we have the drought impact also. And for example, this year, for the seasonal forecast, we forecast above normal rainfall, but the distribution was not that good. So the maize at a sensible stage had a big impact, and at the end, the production was not good. So this is where now, and those, I have said it already, those extreme events are causing loss of lives and livelihood. And with climate change, it will be worsened. And now coming to the cruise project, it has the aim to improve the operational capabilities and to be able to deliver an early warning. Early warning, we have in terms of weather, but in terms of climate also. Because if we take, for example, the seasonal prediction, we should be able to appreciate the quality of the coming rainy season. And with crews, we will move to the seasonal to sub-seasonal. It means that there is a way to appreciate how the distribution will be, because we are going to the sub-seasonal stage. And we also need to appreciate the risk information for agriculture and food security. So, and how can we achieve that? It's going through the capacity building and strengthening cooperation between different institutions. And as Max said already, we move from global support to regional. We have the global, regional support to the national meteorological services. And one example we will show. We already showed this, how we call it, how to achieve with the different component. So we have generally the German Met Office. We have Météo-France also. We have some regional centers like ACMAT and AgriMet, and they will help us to achieve those goals. So, and what I can add is that because we need an accurate weather forecast or seasonal prediction, so, and crews will help us to improve what is already on ground. Thank you.
Thank you very much, Michel, for a very concrete presentation.
Yeah.
So as I mentioned earlier on, we do have a few minutes to take some questions for both the interventions. I remind you that this is just the first part, that we have an important set of interventions after this. So we can take a few interventions and then we'll pass to the second part, which actually will be co-facilitated by Aminda Leigh. I mentioned that because I want to show there's a very good gender parity between the facilitators, which has not always been the case with the panelists. But we're very happy about that. Anyway, any questions, interventions? The gentleman in the center, please. If you can keep them quite succinct and brief, yeah. And maybe give your name and affiliation, please. That'd be appreciated.
I'm from India.
Okay.
I work in forestry sector. My question is that whether any application on forest fire detection is possible with this kind of system, and is there any already operational system existing?
Yeah.
We may take a few questions and then we'll come back to the panelists. Please, sir.
Thank you. My name is Yvan Biot. I work for FAM Africa, which is an international NGO that supports agricultural projects in Eastern Africa. We regularly receive a variety of products to give us an idea of how the season is going to look like in the future, so seasonal forecasts. We get them from the regional climate outlook forums, we get them from ERI, we get them from a variety of sources. How do we as users find out which one is right and which one is of the quality that we would expect?
Yeah.
Thank you. We'll take one more and then we'll go to the panelists and we may have a second round afterwards. Thank you.
Thank you. Caroline Ginmer from France, youth delegate. I wanted to ask what are the main achievements of crews according to you and the major challenges that you face. Thank you.
Thank you very much for that first round. Who wants to go first?
Okay.
Michel, please.
Okay, thank you. So for the forest fire detections, we have one station which is giving us some satellite images, and there is one department dedicated to that, to follow, they call it AMSD stations, and from there they should be able to follow the forest fire detection. But I can say it's not a big issue generally in my country, because when you take the whole country, half of it is a bit dry. So it's mainly in the south you can get thick forests. And generally, forest fire, we may find some at the end of the season, but it's not really a big issue. But we have an office dedicated to that. And they were asking also if there is any operational system existing. Of course, there is already an operational system, but it has also some challenges. We may produce the different information like weather forecasts or seasonal forecasts, some early warnings, but to reach the end users is a challenge. Through some project, we are able to, send some messages with some partnership with private companies, but we cannot do it for the whole country. Even with the cruise project, we may send early warning system, but it won't be. We don't have found for the whole country. It will be at some specific pilot zone. So there is an operational system already, but it's never perfect. If you take, for example, the forecast accuracy, it has to be improved. And it's never perfect. If I take, for example, when we are, what we are giving to the GTS, GTS is the global telecommunication system where we send some data set. The resolution is a bit low, but through some previous project, we got some new weather stations, and with cruise, we will use those data sets to improve again the forecast. And as Max said, it's like, using different sources of data, putting them together and try to reinitialize those models and add some values to the output. Which one is okay? The one was saying that they have products from many centers, and at the end, they don't know which one is wrong or which one is right. But generally, when even within the cruise project, we don't want the spoon-feed product. It's like the different product we'll be developing. We will do it together with those regional and global centers. And we know, when you take all those global centers, they are running their models at the site, but we living in the same place, we know we have the data set, we know more our climate. So by doing it ourselves, we are able to, say, okay, the model maybe here is wrong, maybe here is right. Why? Try to find an explanation and try to correct it with the, because expertise is there at regional and at global, but sometimes the local knowledge also is important to improve the forecast. So we believe that with those initiatives at the end, we should be able to deliver better product. This is what I can say for now. Thank you.
I'll just add to what Michel was saying on the seasonal forecast question, then maybe try to answer a little bit the question about the achievements and challenges of cruise. WMO, the World Meteorological Organization, is a very old organization. It actually started in the 1800s to help meteorological services exchange observations because of this phenomenon I mentioned earlier, that to know what's going to happen in any one place, you need to know what's happening everywhere else. So it's very formalized. It has to be. That's the only way all of this could work. And so the answer to your question is the authority in a country is the National Meteorological Service, and that's often illegal as well as a matter of fact. And at the regional level, it is the ARCOF consensus forecast, which you should treat as the official forecast. Having said that, however, there's plenty of scope for improvement in both domains, and this is one of the things that Météo-France, I think, will really help us with, because Météo-France is the designated node in Europe for seasonal forecasting. So if we combine what Michel was just saying with the model outputs that a Météo-France can provide, the downscaling and tailoring in Burkina Faso should be the best that's possible, you know, with today's available science and technology, and that's what we're shooting for with this project. So we will hope to see real improvements in skill to the extent that they can be improved at the country level. But also the ARCOF system is undergoing a transformation because we want to move to an objective-based system, and I think we'll hear from Jean-Noël Thépaut about the Copernicus Climate Change Service maybe in the next panel. We're starting to get multi-model ensembles that should be able to give very high skill predictions for the regions, and we would like to just set up the configuration of each so that it gives the best skill over West Africa or over Western South America or whatever domain you're interested in, and then do the downscaling further to the country level with statistical methods. So, sorry, this is a bit of a longer, more technical answer than I sort of intended when I started out, but you know, you kind of encouraged me, I guess. So this will take the human element a little bit less expert judgment of who's in the room. You know, what do you think, John? I think it sounds like it should be about half and half, to a model-based output like how weather forecasting is done, and the expert judgment will go into the design of that rather into second-guessing the outputs. So there are some changes on the horizon that I think will, you know, kind of tell the users how much skill we really have in the regions and how much confidence you should put in the forecast. In terms of crews, I can turn that one over to John, but it's very early. These two, the projects that we're talking about are the most advanced ones that we have. There's one other one that's really under any real implementation. So we can't say, you know, how many lives have been saved or anything like that yet, but the real benefit has been, from my point of view, that the World Bank and WMO have been looking for a way to try to hook their financial and program delivery capacity to WMO's deep network of national, global, regional centers and technical experts. And CRUISE gives us that mechanism. So this is the real exciting part about it from the CRUISE institutional point of view, is that we finally found a way to do this on a semi-systematic basis. So it's very small initial steps, you know, a country regional configuration here, another one in the Pacific, we'll start in the Caribbean, but it could snowball, and that has some real potential.
Thank you, Max. And if I'll just add a couple of points on the last question we got to. I will. On the challenge side. No, just to mention, I mean, so we have initial, as Max said, it's very early days. We have initial investments in Niger, Mali, Burkina, Congo. We've a regional project in the Pacific, and we just approved a project in the Caribbean and for Papua New Guinea. And I think one of the interesting, let's say, at this early stage perspectives was the fact that all these investments were then done against the long-term programming perspective. There's often many different entities and projects around this area of work in any one given region. And we didn't want to be another one of those. So because of the structure of the CRUISE, which is a pooled trust fund with multiple donors contributing to one mechanism and multiple implementing partners, we were quite extensive in ensuring that we did our groundwork and doing quite detailed mapping of what are the other initiatives that are ongoing, what are the needs of the countries, and so on. In particular in the Caribbean, we did a very thorough job in that regard. And another one of the early successes is that too often we see a lot of work going into what we call the prediction, data, forecasting component of this work, and separately a lot of work going into working with vulnerable communities to address their climate change adaptation capacity, address their risk to disasters. And these systems don't talk to them sufficiently. And with the setup of the crews, the fact that we had WMO, who has both the forecasting, prediction, data component in its work, but is also very committed to disaster risk reduction. On the World Bank side, we had the Global Facility for Disaster Risk Reduction, and then on the UN side, UNISDR. How it reflected at a country level is that we started actually seeing a better integration of these two worlds. So in Niger is actually a ministry that is in charge of disaster management, which is actually leading the cruise project with the Met services, with the water departments and so on. And so they're building on risk information of the vulnerable communities in some of the neighborhoods of Niamey and so on. So we're starting, even though it's a very early stage, to see some of those aspects. And maybe on the challenge side, just to mention that we're in an environment where the demand is much higher than the resources currently available. So we've got a much higher list of countries who are interested in engaging in cruise than we currently have the capacity to do so. And of course, that's something we'd like to be able to address in the near future. We're slowly running out of time. If there's one more burning issue that you really want to have addressed now, we could take one more, but then we're going to be passing to the floor to the second lot of interventions. Any burning last question? Very good. Okay, so thank you very much for your time. Can I just thank our two panelists, and in particular Michel and Nikiema, who's come a very long way. Thank you very much for that. If you want any more information on the cruise initiative, we do have a website. On this banner here, it's written in pretty small, but it's cruiseinitiative.org, unsurprisingly. So I'm going to pass the floor now to Aminda for the second part. Thank you very much.
Thank you. Thanks, John. Thank you. Very interesting. And in fact, in a way, this should have been the other way around, because the panel that we're going to hear from now are the people who are providing the data that help crews come up with their early warning systems. But all part of that quiet revolution we've been thinking about and hearing about. My name is Aminda Leigh. I'm a former BBC journalist and broadcaster, now living and working out of Rome, specializing in climate change and the environment. For the next 45 minutes of this shared session, we're going to be looking at how climate change forecasting can be supported by open climate data and information. Today's discussions, this part of the discussion, has been organised by Europe's Eyes on the Earth, namely the EU's flagship Earth observation programme called Copernicus, the European Centre for Medium-Range Weather Forecasts, ECMWF, and the European Organisation for Exploitation of Meteorological Satellites, EUMETSAT. We're going to be hearing more about how these three organisations work together during our panel discussion. We're going to be hearing from 5 experts covering all the different aspects of the concrete support that's available to the public and the private sectors in tackling climate change issues, both globally, in Europe, and on a local level. I'd like to now ask the panelists to come up on stage, and we will put your name tags on, and if you could come up on stage. And as they're coming up, I'm going to tell you who we'll be hearing from and how this session will work. We're going to be hearing from each speaker. There's going to be no presentations, and hopefully we're hoping to have some time for your questions at the end as well. Before we start our discussions, please do check your mobiles, make sure they're on silent. And I will now, as our panelists sit down, I will give you a brief introduction as to who they are. So just about to take his seat is Hugo Zunker, who is a policy officer in the Copernicus unit at the European Commission's Directorate General for Internal Market, Industry, entrepreneurship and SMEs, known as DG Grow, much easier to say. He's in charge of the implementation of the Copernicus services for atmospheric monitoring, climate change as well, and he also coordinates the cross-cutting aspects between the various Copernicus services. Filipe Lucio is director of the World Meteorological Organization's Global Framework for Climate Services, or GFCS, and he's been a key figure in the development of its implementation plan. He has a background in operational I can't say it. Okay, weather forecasting. Serving as the director of Mozambique's National Institution of Meteorology. I am not going to do it today. Okay, all right, please excuse me. He recently played a key role in the development of climate research for development agenda for Africa. Jean-Noël Thépaut is head of the Copernicus Climate Change Service, known as C3S, managed by ECMWF. He has a background as a scientist at the French office and has concentrated on how to exploit a wide variety of satellite data, first for numerical weather prediction, and now in the development and production of state-of-the-art climate reanalysis. He served on a number of international committees at EUMETSAT, NASA, and the European Space Agency. Then we have Jörg Schulz, who's Climate Service Product Manager at EUMETSAT. He's involved in 4 European research projects, plus the Copernicus Climate Change Service. He was recently appointed as chair of the Joint Working Group on Climate, involving more than 40 space agencies from around the globe. And last but not least, on the far end, we have Vincent-Henri, who is head of the Copernicus Atmosphere Monitoring Service, also known as CAMS. He's been involved in the design and development of Copernicus for over a decade and has been a member of several international scientific and advisory committees. Please do welcome our panelists. So we're going to start our debate and our discussion here today looking at what the Copernicus program is, for those of you who don't know it. And Hugo is the best person to tell us all about that. And so can you tell us in a nutshell a little bit about Copernicus? What is this program?
So thank you, Aminda. So I think I start a bit with a couple of sentences recalling a bit the overall context of this. So indeed, Copernicus is the European Earth Observation and Monitoring Program. It has quite a long history, so first ideas to have something like this date back to 1998. By now, or by 2020, the European Union, together with the European Space Agency, will have spent around 6 to 7 billion euro on that. So we see that this is a significant investment. I would like to emphasize here as well that this is not a research type of activity, but this is really operational budget on one hand, but we have as well the ambition to really run an operational program. So what does it mean? So we aim at a very high availability of our services, of the data provision and so on. We have a very rigorous quality control in order to make sure that these products continuously meet the expectations of our users. And I think in particular when we talk about climate, one of the most important parameters here is the long-term commitment. So this means we are really here setting up a program which is supposed to stay there for a significant period of time. So, and it's not going to go away over the next years. So why are we doing all this investment? So I mentioned the amount, quite important. So I think we expect from the program not only to contribute to science and science advance, but as well to generate really concrete benefits to society, which are based on it and are enabled by Earth observation. So previous speakers have elaborated one very good example. So where we really expect, based on Earth observation, modeling behind, and so on, to provide concrete benefits. Very important here is that all the Copernicus data, Copernicus products are really made available under full free and open data policies. This means that everybody can access without any cost this data or any license fee, so and can build its own application and its own specific use case around it. So what is basically inside the program? So I would like to mention here a very significant part is the space component, i.e. the satellites, which really circulate around the globe and perform observations on a systematic manner. So these are really there are six satellites up there. So recently we have launched the Sentinel-5P to monitor atmospheric composition. There's a 7th satellite ready to be sent to the launch pad, hopefully to be launched soon. And then there are contributing missions, what we call, which are Sentinels not owned by the Commission, but are run by third-party operators. So, for instance, very important here to me to mention here the meteorological satellites. So I made it. And then all of this together with in situ data, which are taken somewhere on the ground in situ, are feeding into services. And the services, I would like to emphasize, are really the unique characteristic of our program. There are a set of 6 services which are provided in a coherent way to provide products which really help people to benefit from that. So our partners here, Aminda has asked me to briefly touch upon this as well. So for the space component, or what is concerned with satellites and operating satellites, so we rely on our partners, ESA, European Space Agency, and EUMETSAT to build, develop, deploy, operate all these satellites, and to make the data of these satellites available to the program and to everybody. And then for the services, there are a number of what we call entrusted entities to run these services for us. I'm not going to mention all of them here. I would, in this context, highlight ECMWF, because ECMWF is the entrusted entity for us to run services dedicated to atmosphere and to climate change. So maybe I would make one concrete example here. So what do we mean? So all this data is then combined, as we heard as well before in the example of the early warning, is combined with local data, with maybe completely different ancillary data, economic data, whatever, to generate then analysis which are very specific in some cases to specific sectors. So I have an example here mentioned from forestry. So where based on all this data, which are global nature, global modeling, and so on, this is further broken down and applied more and more to smaller scales. At the end, there are products to help a forest company, for instance, a forest operator, to decide which kind of trees he should plant now in order to be able to reap them, to harvest them in maybe 50, 60, 80 years from now. So we have examples here on from Sicily, where climate is changing. So the forest who is currently there, the type of forest is not doing very well anymore in this changed climate. So I think I stop here, not to eat up all of the time. I hope this is giving a bit the flavor of the program. Thank you very much.
Thank you. Yes, and I would like to take this concept of services a bit further with you, Filipe, because can you tell us? We're hearing more and more about this climate services, and which seems a strange phrase. Can you just tell us a little bit more about what they mean?
Thank you. But before I define what a climate service is, I'd like to quote a poet novelist who you might have read, Mark Twain, who said, "Climate is what you expect and weather is what you get." So that gives you an idea of the time frames, and very often we tend to mix the two concepts together. But if I were to use the definition as we use them, climate services can be defined as the provision of climate information in a way that assists decision making by other individuals or organizations. They relate to the accumulation of knowledge about the past, the present, and prediction of the future climate service, and consist of the development and delivery of a range of data, products, and advice based on the knowledge of the past, the present, and the future, and its impact on natural and human systems. So there could be many different types of information that can be considered climate services. But to be a climate service, you need to add some value to information, because there is a difference between what is information and what is a service. And information becomes a service if it addresses a specific need of a particular user. And I could give you examples. We could have historical climate data sets, we could have climate monitoring, we could have climate watches, seasonal forecasts, and climate projections. And depending on the user needs, these data and products may be combined with non-meteorological data, such as agriculture production, health trends, population distributions in risk areas, road infrastructure, and so on and so forth. And from that combination, we derive the socio-economic impact that such events can generate. And then when we go from what a data set is, for example, a series of data, into a potential impact on a particular social and economic sector, we are moving into the domain of climate services. And they've been quite useful. We could cite a number of examples. For example, disaster risk managers can use seasonal forecasts to put up contingency plans to deal with the potential occurrence of a drought or of a flood ahead of time. But you could also have health authorities who could plan for vaccines if certain thresholds of temperature and humidity, for example, are being expected. So there is a range of data products that could then be translated or transformed into a climate services if that information is addressed to specific needs of the user. Now, finally, as we move into this sphere of climate services, one key element that we promote is the concept of co-development and co-production of services. That means the providers and users have to find a common interface where they understand what are the requirements, and then from the understanding that those requirements, tailor the product to address specific needs.
On the listening to what you were saying, obviously it's quite a massive amount of data relevant for a local level. So what is the global framework for climate services?
The global framework for climate services is this intergovernmental and global initiative established by the Third World Climate Conference in 2009. And if we go back in history, we remember that the first World Climate Conference gave birth to the IPCC. The second World Climate Conference gave birth to the United Nations Framework for Climate Change. And with the third conference, we established the global framework with the aim of enhancing the production, availability, and application of climate services. The premises for the establishment of the framework is that availability of climate services can support effective climate risk management and adaptation to climate variability and change. And that can only be possible if we enable the world to have robust, in terms of science, and relevant, meaning tailored to address specific needs. Now, the framework is established because to ensure that the world can benefit from good climate services, there is a range of activities that need to be undertaken, from observations, from research, from capacity development, from having the systems in place for data analysis, data processing, predictions, and then eventually to communicating the information to users, but also enabling the dialogue, as I was saying earlier, between users and providers to come to an understanding of what needs to be done. So the framework basically is there to enable a global cooperation that will result in development of capability, and in that process we basically work in collaboration from those who can provide certain capabilities to those who don't have capabilities, and that's how the Copernicus becomes part of something that we could talk about later. So finally, the framework is there to support that capacity development, but it has identified a number of priority areas, which are 5: agriculture and food security, water, health, disaster risk reduction, and energy. Because those are areas where if we can make progress in the use of climate services, we would be we would be realizing much better outcomes in terms of improving livelihoods and lives of people, particularly in the developing world.
And just a couple of minutes on how Copernicus does fit into this picture.
We developed, or the framework, the global framework for climate services, has been developed mimicking the current infrastructure which exists for weather forecasts. And in the process of producing a weather forecast, no single country works together. There's an operational infrastructure which enables the exchange of data and information globally, which countries can use to then generate their weather forecasts. So we have a 3-tier cascading implementation approach within the global framework for climate services, through which we have existing established global producing centers which generate numerical weather prediction data and products, which are made available to regional climate centers who post-process that data, and then they make that data available to national meteorological and hydrological services in other institutions at the national level, which then generate tailored climate service to users. So the Copernicus becomes part of this global infrastructure which generates data which will be made available to regional climate centers and national institutions for them to generate tailored products for specific users. And it's particularly important, and I'd like to commend the Commission and others who have been behind the establishment of this product, because in many parts of the world, the quality and quantity of data for climate services is not adequate. And we could cite cases of Africa, parts of Latin America, but also parts of some islands in the Pacific, where the quality of observations is far below what is needed to better understand the climate system, but also to predict the climate in the form of different types of prediction ahead of time.
Thank you. I'd now like to turn to Jean-Noël Thépaut, who's head of the Copernicus Climate Change Service, to find out more about the information and the services that it provides. Can you tell us a bit about that?
Yeah, thank you. Well, first, meteorology. You see, it's not so hard to say.
I'll do my homework afterwards. That's certainly easier, yes. This time French beats English.
Yeah. Anyway, so C3S, Copernicus Climate Change Service, is one of the 6 core services of the Copernicus program that Hugo referred to in his speech. And our role really is to support policymakers, public authorities, decision makers. It can be centers working for the GFCS, as Filipe mentioned, and all these authorities which are in need of climate information or environmental information. So this is where we are, and this is what we are for. So how we do that? We are ambitious enough to provide a comprehensive picture of the climate, so covering different timescales, and we provide climate information from the past, from the present, and for the future. So in the past, we are talking about historical climate data records, reanalysis, which combine models and observations to provide maps without gaps, if you want. Seasonal forecasts, there were discussions about seasonal forecasts in the previous panel. We are developing a multimodal seasonal forecast product, and we would like to play a role in the evolution of the ARCOF system that Max Dilley was referring to previously. And we also cover the climate projection timescale, so what will happen within the next 50 or 200 years. And the idea is that from this information, relevant climate indicators are generated to serve a wide variety of users.
Why do you have to reanalyze the records of the past? Why is that important?
I think there are three aspects. First, when you want to assess the current climate, you have to put it in a longer-term perspective. You have to put it in a context, a much longer context. So you need to know what was happening 20, 30, 50, if possible 100 years ago, or maybe more. If we had observations before, we would do that as well. So you need to put the current climate into context. So that's the first answer. The second is that the science is continuously evolving, new technologies, new computing capacities, new algorithms to exploit observations. And thanks to this science and new technology, we can do much better. We can exploit more the observations that we had in the past. We can extract more information about them than we were able to do recently or in the past. So it's very important to keep continuing doing it, to have a better description of the climate, the past climate, by improving the science. And the third aspect is that we are using a lot of climate models and climate projections to try to understand what the future climate will be in 50, 100 years. But for doing this, we need to have some confidence in these climate models. And to have confidence in these models, we need to check them against observations and reanalysis to have confidence in what they are going to produce in the future. So I think there are these three elements, I would say.
Thank you. Fascinating. I thought it was just about collecting new data. I didn't realize they would go back to the old data. And on the idea of concrete support, we've already heard some examples, but can you give us some more examples of the type of concrete support that you provide to the public and also the private sector?
Yes, so beyond the sort of authoritative information and sort of generic climate indices and climate indicators, we are also providing a number of case studies with public and private sectors. I mean, one very good or very thirsty customer of our climate service is the wind energy sector. So they are in need of climate information to decide where they are going to install their wind farm, for example. And I was in contact with a colleague recently who is running a private company doing this, and he was telling me that, so I read because I don't want to get the figures wrong, 1% error in wind speed estimation can generate roughly a 2.5% error in the annual energy production estimation. And that translates immediately in 2.5 million euros for a 100 megawatt project. And now we see several hundred megawatts or gigawatt projects. So that tells you the sort of money that is behind this requirement. And another example is maybe with a smaller size project that we had recently with Heineken, the brewery company in the Netherlands, which is very interested in knowing the quantity, so the river flow and the quality of the water that will be available in the next decades or so that they can plan their activities and have a development plan to be climate neutral. So they are also asking intermediaries which work with us, in that case it's University of Wageningen, to derive some information from Copernicus data so that they can plan better their activities, so that we don't run into a planet where there is no beer available in 50 years from now, which would be a total disaster for many of us.
Yes. Okay, well, I don't know quite how to react to that thing, the idea of a world without any beer. Anyway, we've been hearing also, and you talked about this, Hugo, a bit, about monitoring greenhouse gases from space. And so I'd like to ask Jörg Schulz about that from EUMETSAT, particularly the types of examples from your perspective as to what you do.
Yes, so we'll probably not right away talk about greenhouse gas as we did that yesterday at length. So, but as Jean-Noël mentioned, so the analysis of past data is very important. And if you look at satellite data, so those go back basically to the mid-1960s. So the first satellites were basically launched for observation in 1966. So those data are still not really accessible and usable for the activities that Jean-Noël just described, but we can still work on them to probably make them usable. So in my organization, EUMETSAT, for example, we hold about more than 40 years of Meteosat data. You may have seen those when you look weather forecasts on the TV, whenever you see these satellite movies over Europe or Africa in particular. So that's the Meteosat satellite. It was built really to observe weather, and nobody was thinking about climate. So, but now we actually go back and reanalyze those data and try to really understand the individual instruments. And the 40 years, that means basically 10 different satellites in a row. So we analyze instrument by instrument and try to improve that. And very recently, we have actually were able to recalibrate those instruments to produce a nice time series of their measurements. And that, of course, enables us to then derive from it things like land surface temperature, sea surface temperature, and other of these so-called essential climate variables. We have also missions which are newer, so basically launched about 10, 15 years ago. So in our polar orbiting satellites, so those are much more accurate. So at that time, the people were already thinking about how accurate we need to be to detect a climate signal if we continue those measurements over 50, 60, 70 years. And one example of that is also connected to the Copernicus activities of the EU, is that we are a co-operator of the JSON satellite. So that is measuring sea level and sea level anomalies. And these are very accurate measurements, and we just start to explore this not only in a global average sense, but also regionally, so that you can see how the sea level is changing in coastal areas. And that is, of course, very important because very, very many people live there. The satellite that we operate, so we operate 2 at the moment, and there will be a new one, the Sentinel-6, in the future. So those are connected to earlier measurements done by NASA and others, and this goes also back to the 1990s. So this is also building up a very nice long time series of this, and all these data can, of course, be used within the context of the reanalysis. I think Hugo mentioned that sustainability, so that we really have these long sustained programs. So that's not only Copernicus, but also our member states. So we're a member state driven organization, has made really commitments that we can continue the meteorological satellite programs at a scale of measurements up to the 2040s already. So this commitment exists, and that is really homogeneous to what we have measured before, so we are in a pretty good position that we can really do these very long time series also in the future.
We have heard, though, that you're reanalyzing the data now in the light of the new technology, etc. So if we think about the data that you're gathering now, which will probably go for reanalysis in the future, but how strong is the data now, and what can you do to make it more reliable for the future?
Yes, so of course, whenever you want to analyze climate change in particular, so that's a very small signal over a very long time. No? So if you have data, you need to really be very stringent in your quality characteristics. And of course, the reliability of these really depend A, on the quality of the measurement that was taken in the past, and B, also about what do you know about the circumstances of this measurement. So that's what we call metadata in the field. So the description of how the measurement was taken and what co-measurements were taken to calibrate the instrument. And these things are so documented in various ways, sometimes on paper if it's very old, or really digital. So you need to use and utilize that information to improve the past measurements. And then of course it depends on if we are able to reprocess the data with the newest algorithms or an improved calibration. And then we can of course put it into a reanalysis, for example. So saying this, I would say so that the data records that we have now are already pretty reliable, and the newer ones are even more reliable because the instruments have just better data quality. No? So, but still, also for those, many things happen to the instruments in space. There's very hard space radiation, so they get also broken. So you need to really monitor that very closely and then act and react to that. And one point that I also want to make is that the process of understanding the measurements also involves an estimation of uncertainty. And that's a real matter of research. So if we have these old measurements, so how can we actually understand what the uncertainty of that measurement is? Can we quantify that? And we have currently, I think, at least 2 or 3 EU research projects that are actually addressing these questions, and that will also lead to new information for the reanalysis that could be used in the process of data assimilation there. And it's very important because if we know the uncertainties, we can communicate that to our customers. So Jean-Noël is probably our best customer at the moment with this, and that helps them to correctly use these measurements. And if we do that, then it allows also to communicate to the end users of the reanalysis in some way that the confidence and statements about climate change become more reliable, because we really know what we are talking about. It's just not that we show a graph with a curve increasing from the left lower corner to the upper right corner, and then we say, okay, that you take that as truth, but we probably know better that the truth might be a variation of that curve. No? So, and that information needs also to be provided with that. And in the very end, it is always that the applications will tell how reliable those are, so you need to bring them, in the best case, in different applications. And what we see is that they are very heavily used in the reanalysis, so that's basically the base data directly from the satellites, but also many derived products from those data are also used in this field of evaluating the quality of climate models that do these long-term projections. And we see an increasing use of satellite data, so something we must have improved something that is really enabling the modelers using those data, because they do not know anything about it. No? So they are very critical in taking up new data sources, and that is something that we have managed and very much improved in the last 2 to 3 years.
Thank you. Interesting to hear about uncertainty in our post-truth world. It's not something that often people talk about. And I'd like to now turn to our final speaker, Vincent-Henri, who is head of the Copernicus Atmosphere Monitoring Service. Can you tell us a little bit about the link between climate change and air quality, which is, let's say, 2 things that you're looking at?
Yes, I think before telling about the reasons or cause why those 2 issues are related, the first thing is that the fact that it is related is both a doom and a benediction. So it is a doom because the 2 aspects are related through human activities, and namely human emissions. So combustion of fossil fuel not only emits CO2, but they emit also a range of other gases and particles, and these gases and particles have an immediate impact on health, ecosystems, and agriculture. There was a paper very recently published that had lots of impact in the Lancet, showing that about 9 million deaths in a year in the world are caused by air pollution. So air pollution is a major problem today. And going also into answering a question that was asked in the first panel, today we have some means to answer certain questions. There was a question about fire from a gentleman from India. And today, within the Copernicus program, we are able to monitor these emissions quite accurately, actually. We can predict within 10 days in advance the risk of fire. And if the fire has been ignited, then satellite observations start to capture the fire. So we can deduct the amount of CO2, but also the amount of particles and other gases that are emitted by that. And further, we can forecast over the next few days how these particles and gases will impact health of the people. So the two aspects are closely connected, and there is a doom aspect. But there is a benediction aspect. That is, because air quality affects our generation, and climate change will affect increasingly the future generations, there's no longer a choice to be made. That is, if there's a way to fight or to mitigate emissions today, there will be benefit all along the line today with air quality, air pollution, and for the next generation in terms of mitigating climate change.
So obviously there are synergies in improving the air quality and also fighting climate change. What's happening to, let's say, make the most of those?
Yeah, so as a principle, if you mitigate emissions, you will get a principle on both sides. But actually, when you look at in detail at the detailed processes, it may not be so. There is a very well-known example in the field, which was linked to car emissions. So there were policies in some countries about car emissions in terms of gram of CO2. And as a result of these policies, car manufacturers started to make cars that emitted less CO2 and CO2 below the threshold that had been defined. But because this early legislation didn't have anything about emissions of other gases like NO2, like carbon monoxide or particles, actually this was making the situation for air quality worse. So yes, there are some very strong and joint benefits to SAIS, but at the same time, the way these policies are designed should be really comprehensive and look at all the aspects that are connected. And as a matter of fact, I use the example of car. It's an excellent example where when this has been observed, actually from observations of air quality showing that these countries which were expecting to do good for the environment were experiencing deterioration for air quality. Actually, the monitoring and the legislation could change to redress that. So that's a very good example that monitoring is a very good complement to deciding and defining policies.
Exactly. In fact, I was going to ask you how Copernicus provides that holistic picture and also helps us avoid these, let's say, rebound effect or minimize them as much as we can.
Yes, I think the tagline of Copernicus is the eye on Earth, and this should not be understood as a big brother which is watching and looking and being the police of air quality and CO2 emissions. That's not the spirit. Actually, the spirit is really to have a kind of top-down, bottom-up, handshaking approach. So the bottom-up approach is the accounting of emissions for carbon, of course, but also for the pollutants, which is done as good as possible at the country level, etc. At the same time, we have observations in the atmosphere, which are picked up by satellites, which are picked up by in-situ observations, and these can bring some views whether the estimates which are done bottom-up and these observations which are giving the result in the atmosphere are matching or not. And this is a very fruitful circle, because then it is possible to see whether the measures that are taken are really effective. And sometimes the measures are not effective for reasons that are not understood at the time they are taken. So Copernicus' aim is really to bring to the table of negotiation the latest truth about the atmosphere. It's like a doctor providing a set of measurements of the patient, and then it's up to the negotiators to see what's going on and what has to be done.
I think that's what's happening around us here at COP23. Exactly. Okay, we do have some time for questions. If you would like to put up your hand, if we have anyone who would like to ask our panelists anything. There's a lady here. If you could tell us your name and where you're from, thank you.
Hi, I'm Sanam Barak from the University of Heidelberg, and I would like to know what's the limiting factor when doing satellite measurements. Is it the uncertainty of the satellite measurement? Is it the temporal or the spatial resolution? And then maybe also, could you tell me what the connection to the in situ data is, or how you do the quality comparison between those two data sets?
So on limiting factors on quality, that very much depends on what your target is. Of course, if we talk about greenhouse gases, and if we really would pin down emissions or so, then we would say, okay, we need something in space that is actually able to have very high resolution. No? So first in space, because we need to isolate a city at least. No? So that's what you probably want. No? So such a system is not necessarily existing today. No? So this is a limiting factor for that specific variable. No? For others, it depends on how high is the variability in time and space. So that would determine how you need to sample your measurements. No? And there's, of course, always a compromise. So what you need for weather fluctuations or then long-term climate is more about the stability of the data record. So if you have different satellites and you need to bring them together in one time series, no? So there might be similar instruments, but not completely. So at each end of a satellite, you would experience a jump up or down in your time series. And you try to harmonize the treatment of these instruments to avoid that. And the second question on the ground-based observations, of course, it's very important to have ground-based observations. So in the system, if you do a reanalysis, so you need this as well, because the satellites in many cases cannot really see lower parts of the atmospheres on the infrared spectrum or so. So this is like, you need other measurements. Then, of course, we also use those to validate satellite measurements. And that is, it's a very complex task actually to do that, because what you need to do is you need to have these measurements in an idle case at the same time and in the same location, and that's never the case. So that means that you have for certain uncertainty again in these comparisons, and you need to try to quantify that. And that's also true for the ground-based measurements. They also need to have uncertainty estimates themselves, because there's also a measurement like the satellite measurement. And there is a project called Gaia-CLIM. So you can go to gaia-clim.eu, where you can actually see a lot of showcases how these comparisons are made, resolving the full budget of uncertainty of these comparisons. And this is only done in certain locations, because ground-based measurements have also very different quality. So they're really large networks and that observed, but they're not really quality controlled. No? So we need very accurate ground-based measurements in certain locations, and those can also be optimized where to have those ground-based measurements to meet best the satellite measurements.
Jean-Noël?
Yes, to complement what Jörg said, I will state the obvious, but one very strong limitation of satellite data is that before 1970 there is none. So if you think in terms of a climate context, you have to rely on something else as well. That's why all the work on data rescue and the work on understanding the data applies as well to in situ observation, and that's really a fundamental element of a climate service, I think.
Thank you. We have time for a couple more questions if anyone has anything. No? Okay. What I'd like to do is just finish off the panel, just doing a quick summary of the points to take away that people can take for the future as to where we're all going on monitoring our climate. Hugo, would you like to give us a sentence or two?
Sorry. Well, yes, I think now as a program manager here, or from the program management here, I would like to state more or less that these past years in the operational Copernicus program really went very well. I would like to thank very much all the participants here, in particular Atmosphere Climate Services, which helped us to provide already now, after quite short time, very reliable, high-quality data, which is recognized very much by other entities. Not as last, we can mention WMO in the State of the Climate report is making reference to activities under the umbrella of the Copernicus program. So I think that's a very nice achievement, and I think we are very proud of that.
Thank you. Filipe?
I'd like to go back to one important principle. When the GFCS was established, there were 8 principles put forward, one of which indicated the need of not duplicating, but making sure that we build on the capability of what exists, and where necessary, build new capability. And so one of the most important things that we do as a framework is to facilitate the coordination of the actions of different actors, the linkage of the initiatives of different actors, to ensure that the investments being made, the expertise that exists comes to bear. Because we've seen very good work, a number of initiatives, but often that work can be or perhaps not achieve the desired outcomes if it's not coordinated with the work of the other. So that's number one. And the second is as we develop climate services, we basically enter into a relatively new sphere. And so there's a need of gathering lessons, gathering experiences, and making that information available for those who want to embark in this emerging field. And so that's another area of interest for the GFCS, or focus of the GFCS. And we are working towards making sure that the work that is being done by the different parts and the contribution that are made by different actors are effectively documented and eventually shared.
Thank you. And in fact, this event is also part of that process as well. Jean?
Maybe very briefly. Well, first of all, I think that the Climate Change Service of Copernicus ambitions to be an enabler, so not only providing data, authoritative data, but also tools, good practices, guidance, and scientific support, so that downstream services can be generated from that. And second, I think we see ourselves as an operational contribution to the framework that Filipe just described.
Thank you. Jörg?
Yes, I think I go in the same direction. So the international coordination is something that's super important. So Aminda mentioned that in the beginning. So I'm chairing a working group for 2 big satellite coordination bodies, specifically on climate. And that is, of course, to coordinate the activities of the space agencies and contributing also to the GFCS. And recently we've built now a big inventory, which you can also find in the internet. Look for ECV inventory, where you can find a collection of all the climate data records that have been derived from satellite data, and those which are planned for the future by basically, I think the contributor was about 12 different space agencies so far of 30 possible ones. So there are still very small ones that can do that. But that's very important to support the planning processes, how we support these bigger frameworks. Also GCOS is in between that. And this goes from, so have we really used all the data in a proper way, or is there more to harvest from past data? But also, how can we better coordinate the planning of satellite missions for climate? Because you always need to make compromises sometimes between weather applications and other environmental monitoring applications, because it's all about cost. But in knowing what we have and what we need is very important to make this planning much more efficient, to spend our money very wisely.
Thank you. Vincent-Henri?
So lots has been said. I think I will finish with a sentence. I don't remember who said that one can only manage properly what one can measure. And I think that's really the spirit of the what Copernicus can bring to this discussion. That is bringing together space, in situ observations, doing a job that is quite complex, quite tedious to do in order to deliver data sets that are gridded, that are easily accessible throughout the world, and with users of a different technological capability is really important. We have no political mandate. We have we pursue no goal, just to bring these metrics to the table for others to take on and use them.
Thank you very much indeed. And that brings us to the end of this discussion. Who knew that climate monitoring could have an effect on vaccines, beer, wind farms, and the forests of the future? Really a very wide-ranging impact. Thank you to all our speakers and for explaining things in a very clear, non-technical way. Thank you to the session organisers, the logistics team, and of course our technicians as well. Please give everyone a round of applause. If you have any questions for our panelists, we do have this room for a short while, so you can also go up to them afterwards. Thank you.